In this video, I'm going to be making 3,5-dimethylpyrazole via the condensation of hydrazine with acetylacetone, following the procedure laid out in Vogel's Practical Organic Chemistry at half scale. This synthesis requires 130 milliliters of diethyl ether, 20 grams of sodium hydroxide, 32.5 grams of hydrazine sulfate, and 25 grams of acetylacetone, which is the 2,4-pentane dione. The sodium hydroxide was dissolved in water to bring the solution volume up to 200 milliliters. This was then placed in an ice bath to cool down and then transferred into a 1-liter round bottom flask. The hydrazine sulfate was then added to the chilled sodium hydroxide solution, forming free base hydrazine. The acetylacetone was measured out and added to an addition funnel. During the exothermic addition, the rate was adjusted to maintain the temperature at 15 degrees Celsius. The precipitate seen in the flask is our product, and after the addition is completed, the mixture was stirred for 1 hour at 15 degrees Celsius. "200 milliliters of water was added to the mixture and stirred for about 5 minutes. It was then transferred into a separatory funnel and the flask was washed out. The mixture is then extracted with 50 ml of ether and washed with 4 20 milliliter portions of ether. You can see some undissolved product in the ether layer, and to remedy that, you can just add some more ether to fully dissolve the product. However, I ran out of ether, so I had to finish the final 3 washings with chloroform, and I transferred those washings into a separate flask. Both the ether and chloroform extracts were washed separately with saturated sodium chloride solution and then dried over anhydrous sodium carbonate. The ether and chloroform extracts were distilled until no more solvent came over. This left the molten dimethylpyrazole in the flask, and it was then poured into a crystallizing dish to solidify. The product was then broken up and left to dry. 12.7 grams of product was recovered from the ether extraction and 5.4 grams of product from the chloroform. The product from the ether extraction had an almost perfect melting point of 106 to 108 degrees Celsius without any further purification. The product recovered from the chloroform extraction was rather crude and had a yellow tinge to it, so it was recrystallized from hexanes. After recrystallization, the product weighed 5.1 grams. However, when I took the melting point, it was 90 degrees Celsius, with the theoretical being 107 to 108 degrees Celsius. So this led me to believe that there was still quite a large amount of solvent remaining in the product. I then dried this at 70 degrees Celsius to drive off any remaining solvent, and I lost an additional 0.5 grams, bringing the mass of the chloroform extract down to 4.6 grams. However, the melting point was now 105 to 110 degrees Celsius, which was a much more acceptable range. The final yield was 12.7 grams of quite pure and white product from the ether extraction, and 4.6 grams of lower purity off-white product from the chloroform extraction. The total is 17.3 grams, which is a 72% yield. Compared to the 75% yield in Vogel, this synthesis was quite successful. And if I hadn't run out of ether, then I probably would have had a slightly higher yield with a purer product overall.